Kale. So this is going to be your 8.1 video that is going to help you learn how to multiply two binomials together in order to get a polynomial. And in Common Core fashion, they're doing it with having you use generic rectangles, which complexes the issue, but that's not for me to say. But we'll show you the way that the Common Core wants you to do it. So I blew up this rectangle here in 1A. The task is to write the area of this rectangle in terms of product and a sum. So let's fill in what we know. That's xy, that's x squared, that's x. Oh, and then we know that this is a y. So now it's just a little bit of puzzle solving. And I notice that these two rectangles are almost the same size. So I know that they both have to be x. This rectangle here and this rectangle here are about the same size. And they are the same size. So those are all x's. This rectangle that's labeled y will be the same size as these. And then we're going to go through and figure out what these little tiny ones are after we figure out the length and the width of the rectangle. So I know to find the area of any rectangle, area is length times width. And so for this first one here, the length has to be y. And the length is going to be going this way. And the width has to be x. And the width is going to go up and down like this. I know that the length is y because they all have the same in that first column. So I'm going to call that y there. And there's my width of x there. So I also know here x times x is going to be x squared. And x times 1 has to be x. So that's how I get my outside here. And then across the side here, I know that y times 1 is y, x times 1 is x, so all of these have to be 1s, which will dictate that those are all 1s as well. So now I have the areas of every one of my rectangles in here, and I've got the length and the width of the big rectangle. So it's time to write this in terms of a sum. And sum, I just add together all the areas, grouping together like terms. So I've got 1xy here. So I write xy like that. I've got 1x squared. So I write x squared like that. I've got 1, 2, 3, 4, 5, 6 x's. That is an x, by the way. So I've got 6 x's. And I've got 1, 2, 3, 4, 5, 6, 7, 8 1s. And that's going to be 8. So that's writing the area in terms of a sum. In order to do it in terms of a product, this is a product, length times width. So length times width here would be y plus x plus 1, 2. And then my width is going to be x plus 1, 2, 3, 4. And so now the whole entire intention of this Common Core rectangle stuff is to show you that the product written as length times width is equal to the sum. And to show that to you, you use the traditional algebra method of distribution. So you'd have x times y is xy, x times x is x squared, x times 2 is 2x, and then I've got 4 times y is 4y, 4 times x is 4x, and 4 times 2 is 8. There are two terms here that you can combine like terms with. That's the 2x and the 4x. So that turns into xy plus x squared plus 6x plus 4y I forgot the 4y up here. I apologize. I got 4 y's. 1, 2, 3, 4. 4 y's up here. Plus 4y plus 8. I hope you see where that 4y came from. I'm sorry. I forgot to add in those 4 y's. The whole entire intention of that first problem, once again, is to show you that the individual areas of all of those rectangles added up will equal the product of the length and the width. So hopefully that first question makes sense. In the 1B question, I will go to another slide here. You've got the 6x, make sure I got the right problem here, 6x minus 1, and then 3x plus 2. This time they're asking you to work a little bit backwards in order to use the product to come up with the sum of the rectangle using what they call that generic rectangle. I'm going to show you the Common Core generic rectangle way, and then I'm going to show you the traditional way that I learned a long time ago called FOIL. I don't know if your teacher talks about FOIL, and I don't know if they're allowed to talk about FOIL anymore in math class, but I'll show you. It's a shortcut. 6x minus 1, 3x plus 2. Just make sure I've got the right answer here. So I'm going to set up a generic rectangle. And with a generic rectangle, when I have two binomials, I'll have 4 terms. So I set up a 4 square. The second one, the width goes up the side. So I have 3x and a positive 2. And the length goes across the bottom, 6x minus 1. And you do exactly like you did in the previous problem. Multiply the width times the length. 6x times 3x is 18x squared. 6x times 2 is 12x. Minus 1 times 3x is negative 3x. And negative 1 times 2 is negative 2. And then I put it together in terms of a sum. So I'll have 18x squared plus 12x minus 3x minus 2. These terms can combine together, 12x minus the 3x. So I'll have 18x squared plus 9x minus 2. And so that's using the generic rectangle in order to figure out the new polynomial. Now, if you don't want to use these generic rectangles, there's something called FOIL. And it's the old traditional way of finding the product of two binomials. F stands for front, O stands for outside, I stands for inside, and L stands for last. So what you're going to do here is you're going to take the 6x minus 1 and the 3x plus 2, and you are going to multiply the first two terms together. Those are the front terms. 6x times 3x is 18x squared. You're going to multiply the outside terms together. 6x plus 2 is plus 12x. You're going to multiply the inside terms together. Negative 1 times 3x is minus 3x. And then you're going to multiply the last terms together. Negative 1 plus 2 is negative 2. And again, we can combine those middle terms again. So I will get the exact same thing as I got up here. So if you don't want to do your generic rectangles and your teacher's not requiring it, that's my easy way of remembering how to multiply together binomials. So hopefully this helps. Sorry about the little mistake on the first problem, but I hope that makes sense.